Hello students, this is lesson U2A03A. By the end of the lesson, you should be able to say I can perform rotations of 90 degrees on a coordinate grid. Actually, corrections here, it should say rotations of multiples of 90 degrees. It should say multiples of 90 degrees. Multiples. Whoops. And the reason why I say multiples is because we're going to be rotating things not just 90, but 180 and then 270. Multiples of 90 degrees. Okay? All right, so let's check this out. All right, so what I want to do is I want to rotate the triangle ABC 90 degrees, okay, with respect to the origin. And the notation is given by this, okay? So the notation is lowercase r here stands for rotation. Capital R stands for reflections. If I have a 90 degree here, that's saying we're going to rotate 90 degrees, okay? Well, which way is it, okay, when something is being asked for you to rotate 90 degrees? Well, actually, interestingly enough, okay, I want you to pause the video for a moment. Are we rotating in this way, like counterclockwise? Is that 90 degrees? Is this positive, or is counterclockwise going to be positive? So one more time, which one's a positive here? In this direction, is that positive? Or in this direction, is it positive? Pause the video and think about this. All right, welcome back. So as it turns out, okay, positive rotation is actually this guy. This is positive rotation. This is negative rotation, okay? When you're rotating something positive, you are doing the following, and this is actually inherent to, like, within our DNA, okay? So which way does the sun rise and which way does the sun set? It always goes from east to west, right? So the sun starts here and it rises, and then at noon, okay, it hits the very, very top, and then eventually the sun will set, okay, over there, right? So this is a positive rotation. This is a positive rotation, okay, and then it'll eventually work its way back. So it is actually inherent within every one of us that we intuitively, okay, implicitly understand these concepts. It's just that what we're doing here in school is we're harnessing that ability and we're trying to develop that skill so that you can articulate it, okay? So a positive 90-degree rotation is a counterclockwise rotation. This is a counterclockwise rotation. Okay, and as it turns out, clockwise rotation is actually negative. All right, so it seems a little confusing, but just the thing to remember is not whether it's clockwise or counterclockwise, okay, but to understand that we are going from east to west. I think that's the easiest way to remember this. Anyhow, the notation, one more time, okay, is you have 90 degrees over here, okay, I'm going to use my highlighter. So we have 90 degrees over here. This is telling us how much to rotate, okay? And then this point right there, if it's not explicitly stated, then it is implied that we are rotating over the origin. So here I am telling you that we are rotating over the origin. We're rotating triangle ABC over the origin, 90 degrees. And how will that even look? Well, the way in which we're going to do this, we're going to rotate all 3 points, point A, B, and C, okay, over the origin 90 degrees. When we're rotating something 90 degrees, okay, this is what's happening. We are moving said object at a right angle, okay? So how is this going to be illustrated? So this is going to be illustrated in this manner. So notice right now, this, okay, connects with the origin. It connects with the center of rotation. Now that line needs to form 90 degrees. It can either go, again, this way, right? Or it can go the other way, okay? It has to go the other way because we are going a 90-degree rotation here. It's a positive rotation. So the triangle here has to end up in this direction. Point A has to end up over here somewhere. Sorry. Point A has to end up not somewhere, but right there, okay? So whatever distance this was, okay, it has to be preserved, okay, moving in that direction there. And then we're going to take point B and do the same exact thing, right? So, but one thing I want to comment on just before I move on to the next slide here. If you look at this, right, this is 90-degree angle here, right? And how do we know this? If you look at this, okay, we're going down 1 and over 2, right? The slope here is negative half. The slope over here has to be positive 2. Observe closely, okay, on why slope comes into play here. When we talk about perpendicular, okay, perpendicular lines, the slope of those lines must be negative reciprocals. Okay, so remember that? So we have to incorporate that when we're performing these rotations of 90 degrees. We have to incorporate concepts of negative reciprocal slopes. The same thing could be said about point B to the origin. So let's look at this. We went down 2 and then over 2, 4, 6. We went over 6, right? So that means alternatively, okay, to get to point B, we're going to go down 6 and over 2. That's where point B is going to be located. And the same thing could be said about point C. So here we're going down 4 and over 3. So that means over here we're going to go down 3 and over 4 to get to point C. All right. So this is a 90-degree counterclockwise rotation of triangle ABC. So here it is again. These are the this was the original set of coordinates. These are the coordinates after the transformation happened. All right, we're going to try to do this again, but this time we're going to rotate negative 90, okay? So negative 90, which means we are going to go clockwise. It's going to end up over here somewhere, right? So again, we're going to do the same thing. We're going to connect the point, each of the points to the origin, and notice that we are going down 1 and over 2. So that means we're going to go over 1 and up 2. Again, to form that negative reciprocal slope. We're going to do this for every single point. We're going to go down 2 and over 6. So that means over here we're going to go over 2 and up 6. And then the same thing could be said about point C. We're going to go down 4 and over 3. So that means we're going to go over 4 and up 3. And here are the coordinates of the original. And here are the coordinates after the transformation has happened. Alrighty. We're going to rotate triangle ABC 180 degrees. All right, so 180 degrees. What does that even mean, right? So 180 degrees means double 90, right? So when we're doubling 90, we are basically just taking this point right here, connecting it to the origin, right? And we're bringing it all the way around. We're rotating it. So it's got to end up over there. So we're going to do this for all 3 coordinates. So a rotation of 180 degree, one can actually think of it as a point rotation or point reflection, where the object, okay, is on the other side of that point, okay, but flipped. And here are the coordinates after the translation, after the rotation. What am I saying? All right. So some of you guys are probably wondering, like, is there a formula to do all this stuff? Because I'm not that visual. You're absolutely right. There is a formula, okay? And here it is. If you're asked to rotate something 90 degrees over the origin, the coordinates, okay, a comma b, will become negative b comma a. If you're asked to rotate something negative 90 degrees, okay, of the original coordinate, it will become b comma negative a. If you're asked to rotate something over the origin, then all you got to do is just negate both coordinates. This is say, again, if you're not that visual of a person, I highly recommend that you take advantage of this little cheat sheet here. 90 degrees rotation over the origin, negative 90 degree rotation over the origin. Right, this was said already. I don't know why I am reiterating this, but yeah, this was already said. Okay, so then there's this one other problem we can, I'm not going to go over this just because this is actually going a little above and beyond like what's really required of you guys, but if you want to try this out, if you really want to try this out, this problem here is a little different. You're rotating that triangle over another point that's not at the origin. Actually, I'll just go over it real quickly, but this is like going slightly above and beyond. You're rotating triangle ABC this time over the coordinate -3, -1. And you're going to be performing the same exact thing. However, the formulas, okay, from the previous slide, these formulas will not work because these formulas are only applicable over the origin, and yet this point right here is over some other random point. So the formulas do not work. So you have to rely on like your visual thinking here. So we're rotating all the points over -3, -1. So again, we're going to draw in these perpendicular lines one at a time, right, to get those coordinates. So finally, you connect these points. Here are the coordinates. All right. And that's it.